All right, so we are going to do 4 warm-ups today. We're going to do these 2, and then we're going to do 2 on the domain and range page, which is the next page. Just a quick note, warm-ups are never homework. Never, ever, ever homework. If you're absent for a day, you can go look at the video of the lecture, and the first thing on that video will be the warm-ups, so you'll be able to write those down. I guess in that case, you might do them at home, in which case you might call them homework, but I never want you to do them on your own. Those are something we do together. I might tell you to work on them in a group, but that's not, we'll always go over them. Does that make sense? I had people all day yesterday thinking the warm-ups were homework, so I'm just checking. Yesterday was very overwhelming, I thought, personally. So, what we're going to do is work on a fraction buster. You have not done a fraction buster since the first semester of Math 1. It's been a good dusty 2 years since you've done that, so we're going to do it together. First question is, denominators, 3, 2, and 3. What is the least common denominator? Meaning, what number does 3 and 2 both go into? Yes. 6. Beautiful. Impressive, amazing. I like to write over here LCD equals 6. And what we do is we multiply all of the numerators by 6. I'm going to attempt to do this problem without a calculator. It's going to be great. Okay, numerators are all the tops. So you want to multiply all the tops by 6. And I want you to visualize in your mind this one here as an over 1 that we just don't write because we're too lazy. Okay, 6 times 1 is 6 over 3n minus 6 times 6 is 36 equals negative. Don't forget that little negative hanging in the front. 6 times 11 is 66 over 2 plus 6 times 2 is 12 over 3n. Okay, let me go over the steps again. First step, find the least common denominator. Second step, multiply all of the numerators by that number. Good so far? Okay, next step, step 3, divide 2n minus 36 equals negative 33 plus 4n. And if you did the first 2 steps correctly, magic will happen and you have all whole numbers now. Okay, and in this point, you can decide what you want to undo first. I'm going to undo the 2n first. You might have a question you're asking your mind. Do I have to leave it as a fraction? Do you guys ever hear the phrase, what happens in Vegas stays in Vegas? You ever hear that before? Okay. How on earth does that apply here? This problem started in fractions, so it stays in fractions and ends in fractions. If the problem started in decimals, we end it in a decimal. This problem starts in a fraction, so you end it in a fraction. Now, lucky for us, we're going to start to use a graphing calculator, which will change all of our decimals to fractions for us because we're too lazy. So just hold on to that thought. Okay, number 7. This is a twins out of jail type of problem. I like to do it with a factor tree. Hopefully, most of your Math 2 teachers did this with a factor tree. We'll see. Does anyone know anything that 252 is divisible by just by looking at it? 2, beautiful. Okay, so it's 2 times something, 126. 126 is also even 2 and 63. I could do that one in my head. 63 is 9 times 7. 9 is 3 times 3. Okay. I'm going to ask you a very fancy question from 4th or 5th grade. What is the prime factorization of 252? Okay, that is a very fancy question. And what I mean is, what numbers that are prime multiply to be 252? And if I want to say it in Mrs. Talbot style, I'm going to say, what numbers are at the end of the branches? 2 or 2 or 3 and 3 and 7. So 2 times 2 times 3 times 3 times 7 is the prime factorization of 252. Why am I asking this? Because when you're simplifying square roots, you don't want to look at the 126, 63, or the 9, because those branched into something else. So you don't look at those when you simplify square roots. Now you think about poker and you're looking for pairs. I find a pair of 2s here. Circle one, cancel the other. I found a pair of 3s. Circle one, cancel the other. Okay, now you're like, I forgot. What do I do? Okay, you take the circled ones, and those come outside and multiply. And you take anything left over that's prime, and that would stay inside. And if there were more of them, you would multiply them, but there's only one in this case. So 6 root 7. Do we remember how to do this? I hope so. Okay, now if you guys could flip the page, please, to the domain and range warm-ups. Okay, this is something you also learned in the first semester of Math 1 that you probably don't remember. It's also very challenging. Domain and range is probably the hardest thing from Math 1, I think, or exponent rules, one of those two. And it's been a really long time since you've done it. This is one of those things I like to call a crock pot concept. Does anyone know what a crock pot is? Anyone ever seen or used a crock pot? Okay. What do we do with a crock pot when we're cooking? Does it cook fast? No, it cooks really, really slow. So this concept cooks really, really slow in your brain, which means it takes a lot of time and repetition and days to figure it out. So I'm not going to expect you to understand this immediately. That's what I'm saying. We're just going to do a couple a day, and hopefully over time it will start to make sense. If you don't get it today, it's okay. Probably 80% of the kids in here won't. Totally fine. Okay, I'm going to remind you that the domain is X and the range is Y. How do I remember that? X and Y is in alphabetical order. Domain and range is in alphabetical order. Okay, this is the x-axis. You're like, oh, I knew that one. Okay, what values of x do these two arrows have? Here and here, I'm marking up the x-axis. What are my two values for x, for these two arrows on this graph? Yes, x equals -3 and 2. There's only two x values on this whole graph. Okay. The range is y, so I'm going to remark up the y-axis. Does this arrow go up forever? Yep. Does it go down forever? Yep. Do you notice that my whole y-axis is covered? Okay, what do I call that? Anybody remember? You probably don't remember. It's called all real numbers, and we write it with this fancy loopy R that has two stems. The reason is because when you write on a chalkboard or a whiteboard, you can't bold an R. It's supposed to be bolded. So instead of bolding it, we write 2 stems. Okay, last question. Is this a function? I can see your brains are trying so hard to remember. Functions, every x has an individual y. And on graphs, we use what's called the vertical line test. So we make vertical lines all along our graph, and we say, oh, does any of my vertical lines touch my graph more than once? Do you see this part right here touches that vertical line more than once? You see that it touches it infinite times? It means it's not a function because it touched it more than once. I promise you that's going to be the easiest part of this whole sheet. It's you don't remember it, but that's going to come back to you the quickest. Okay. Number 2. Remember, if this is really, really hard, it's okay. Domain X. I'm going to mark up the x-axis. This graph goes from here to here. It's kind of like a closed set of values between here and here. My leftmost point is -5, and my rightmost point is 5. Because it's x's, I'm going to put an x in the middle, see if this starts to come back to you a little bit. The left side is open. The right side is closed. Open, closed. You're like, Mrs. Talbot, this is so long ago. It is. Okay, range. Put a y on your y-axis. See, my graph goes from here to here. Here to here. Bottom spot is -2. Top spot is 2. I'm going to put a y in the middle because we're working with y on the range. Okay, super hard questions. Open or closed on the bottom? Okay, I'm going to answer for you. You really want to say open because of this, but it's closed because of this and this. Okay, so the question you're asking yourself is, does it touch -2 anywhere? Yes. If it does, it's closed. Okay, does it touch +2 anywhere? Yes. It's closed. Okay, is it a function? Vertical line test. Am I hitting anything twice with any of these vertical lines? No. So that means it passes. And it is a function. Okay, last thing. If it's a function, state whether it's discrete, continuous, or discontinuous. Discrete is dots. Continuous is something that you would not have to pick up your pencil. So this would be continuous. I'll give you an example of discontinuous when we get there. So continuous graphs, you could draw the graph without picking up your pencil. Okay. Next, I would like to know real quick if anyone got stuck. Did anyone do any of the homework last night yet? Do you have any questions from it? Anything you couldn't figure out? I'll ask again tomorrow. It's okay. Yes. 8. Is it because the diamond is hard? Okay, so did you factor 2 out first? Okay. I think it's going to be 8 and 10 for the diamond. This is the one, right? Okay. You guys think I'm right? So 80 is 8 and 10. Which one of them is going to be negative? Yeah. Can you finish it from there? Okay. Yeah, it's always where everyone gets stuck to the diamond when there's big numbers. That's totally common. All right, you guys. So next thing I want to do is talk about this. Okay, let's read this together. Your first quiz will be Friday. We talked about this already, right? Okay, just want to be clear. This is on Google Classroom, by the way. I posted it this morning. No notes and calculators allowed. Just want to reassure you, if you make a teeny tiny little math mistake, like 6 times 7 is 48 or something like that, I'm not going to mark the whole thing wrong. I'll be like minus a half. Okay, don't worry. I'm not like that. The reason we're not using calculators is because you could drop the line on the calculator without knowing anything, and we can't have that. Also, I want to see what you can do. Okay, 3 questions. The first question is going, actually, I'm not sure if it's the correct order of them, but one of the questions is going to be factoring a quadratic expression. We just worked on that just now. That's diamond box. Might be a GCF involved. Does that make sense? Yeah. Okay. Next one is graphing a line. So like y equals mx plus b, graph the start, count the slope, draw the line. There's some of those on your math 1 and 2 review. There's also some on your quiz review homework, which is tomorrow night. And then solving a one variable equation. That's like everyone's favorite thing where you just solve for x. Let me show you an example of solving a one variable equation. That would be these. Do you know how to do these? Like distribute, combine like terms, undo the stuff, get the number. Notice this is tomorrow night's homework. It's factoring, graphing lines, and solving a one variable equation. So this homework is actually exactly the 3 quiz topics. And then we gave you the answers so you could make sure that you were correct before the quiz. Okay, just so you know. Any questions about the quiz or anything like that? I do want to point out something real quick. I will be checking everyone's transcript in every one of my classes to make sure that you actually pass math 2. And I'm going to be using this quiz and your math score from next week to determine whether or not you're properly placed in this class. So just so you know, don't rule off the math thing and make sure that you're good to go on this quiz, just so there's no question. Okay. Next, can you guys please get out graph paper, graph notebook, whatever you're going to use for this class? You guys did not bring graph paper. I have a big stack of it over here. Help us out. Also, you might want a calculator for this particular activity. So if you brought one, get it out. If you don't have one, grab at least one for your table group. Okay, go ahead and set up your notebook just like mine. Gonna scooch this up for the people in the back, but just don't write that part. That's tomorrow. And that's really glary, so I'm not gonna do that either. There we go. Okay, you guys. So I gave you some function machines, and we're gonna do this fairly quickly because I want you guys to have a lot of time to work on your digital data. That's the last thing we're doing after this. You guys remember about the digital data? Okay. So how is your Chromebook status? You guys have them yet? Okay. So your job in your groups is to figure out the order of which the function machines need to go so that you drop a 6 into the first one, and the answer comes out and drops in the second one, and that answer drops out and drops in the third one, and that answer drops out and drops into the last one, and you get 11. Okay, we're actually going to do B together. I want you guys, and then you guys are going to do A in your groups. I think this works better this way. So could you guys spread out the function machines on your table? All 4 of them. They're not one for each person. They're just, we're going to put them in order. Okay, and we're just going to look at B right now. So I'm going to try to attempt to focus only on this. Technical problems, Mrs. Talbot. Okay. Oh, struggle. Okay. So, what function machine of the 4 makes the most sense to plug 64 into? I'm going to give you 10 seconds to take a look and decide in your groups. Which color of function machines makes the most sense to plug 64 into? I heard it. Does anyone want to venture a guess?
Hey, we gotta guess.
Okay.
This one.
Well, you see what would happen with that one? You would do 64 minus 2 is 62. And 62 squared would be giant. So it's probably not that one. Yes. Okay. It makes the most sense to plug it into the square root one first. Why would that make sense? Because 64 is a perfect square, and when you do the square root, you'll get a whole number. Also, it'll be a smaller number. Okay. Now, okay, square root first. And your answer would be 8, correct? Now, hmm. 2 to the 8, I don't think it's the blue one. How do you feel about that? Do you guys know what 2 to the 8 power is? It's big. What do you venture? So you guys take a minute and talk and tell me if you think the next one is the yellow one or the pink one. Your choices are yellow or pink. Plug in 8 to both of them and see what you think. Can anyone see where it's going? Anyone have any ideas of where it's going? Okay. The next one is yellow. Okay, so the 8 drops into the yellow one, and you have 8 minus 2 squared, which is 6 minus 2 is 6. 6 minus 2 is 6. 8 minus 2 is 6. 6 squared is 36. I heard somebody say it. Okay, now what people screw up on is the negative here. So then, which one makes sense? Am I going to put negative 36 in an exponent? No. Okay, this one makes sense for 2 reasons. 36 over 2 is a nice number, and also the 2 negatives cancel. Anybody know what 36 over 2 is? 18 minus 1. 17. Okay, and then practice on your calculator doing 2 to the 17 minus 7. Do you guys know what the exponent button is? It's right here under the clear. See if you can recreate what I did. Okay. You guys see what my first period was calling this a chain reaction. So 64 goes in, 8 drops down, 36 drops down, 17 drops down. Does that make sense? Okay, what I need you guys to do in your groups, take a few minutes, try to figure out the order that you would place the machines, the initial input to be 6 and the final output to be 11. When you think you have it, I'm going to come check you, and then you're going to work on your digital escape for the rest of the period. As soon as she gets back with the pass, so you look on the whiteboard. Do you see where the hook is? As soon as she gets back, puts the pass up there. Okay, real quick question. Which one is for sure not first?
Oh my gosh.
The square root. Because the square root will give you an awful decimal for 6. We don't want that one first. You can eliminate the square root from being first for sure. Hold on, I need my key. Anyone ready to check? I have one group done. Okay, if you're struggling, I'll give you a hint. It starts with yellow. Starts with yellow. Where's your hint? Starts with yellow. 6 minus 2. 4 squared is 16. Negative 16 comes out of the first one. Would it make sense to plug negative 16 into an exponent or a square root? No. Easy from there. Yes, yes. Okay.
No.
You're all silent and listen. No, go. Okay, so then you start with yellow. Okay, and this one should be green. Okay, and you don't want to put -16 in the next one. Okay, perfect. Okay, so the negative cancels. So 16 over 2 is 8 minus 1 is 4. And then you don't want to put 17. So 2 times 7. That should be 61. And then the square root of 1. What is going on? Are you sleepy? Got it. Okay, do your agility test. Thank you. And not because I care who's fast. As soon as